Welcome to our channel. In today's program, we will explore one of the most critical industries in construction, cement and concrete production. Although these two terms are often used interchangeably, they are actually two entirely different products. In this video, we will delve into the process of cement production, how it is used to create concrete, and the key steps involved in this fascinating journey. Let's get started.
Preview.
While the terms cement and concrete are often used interchangeably, they are fundamentally different. Cement is one of the primary raw materials in the production of concrete. It combines with water and aggregates to create finished concrete. Concrete is made up of three main components: cement, aggregates, gravel, sand, and water. Cement, particularly ordinary Portland cement, is the most widely used type of cement, named after the limestone color found on Portland Island in Dorset, England. The main raw materials for cement production are limestone and clay, which are extracted from quarries using explosives or heavy machinery to mine them from the earth. Once the raw materials are extracted, they are transported to the factory for processing. Limestone and clay are crushed and blended in precise proportions to form a raw mix. This mix is then fed into a large rotary mill where the materials are ground into a fine powder. The next step is preheating in a preheater tower. This critical phase partially decomposes the limestone compounds to form calcium oxide, lime. The preheated raw mix is then fed into a large rotary kiln where temperatures can reach up to 1450 degrees Celsius. Inside the kiln, complex chemical reactions take place to produce clinker, small pebble-sized nodules. After exiting the kiln, the clinker is cooled rapidly by air to reduce its temperature. This cooling process is essential to ensure the quality of the clinker and to prevent the formation of undesirable crystals. Once cooled, the clinker is ground further with gypsum and other additives, such as fly ash, slag, or pozzolana, to form fine cement powder. Gypsum is added to control the setting time of cement, giving it enough time to harden and form a durable structure. After grinding and blending, the cement is ready to be transported to concrete manufacturing plants. With cement prepared, the next step is gathering the components for concrete, including aggregates and water. Aggregates are the most crucial component of concrete, making up 75% of the mixture's volume. They consist of gravel and sand, where sand fills the voids between gravel particles, creating a strong bond. High-quality aggregates are carefully graded to achieve a balance between coarse and fine particles. This minimizes the amount of cement required, reducing production costs. Proper selection and mixing of these components are vital for creating concrete with high strength and uniformity. Additives are an indispensable part of concrete production. These chemicals improve the properties of concrete, making it easier to work with, mold, and place in tight spaces. Additives can also accelerate or slow down the setting process, allowing the concrete to achieve its desired strength within the required time frame. In addition, concrete can be reinforced with stainless steel, glass, or carbon fibers to enhance its tensile strength and durability. These advanced technologies enable the creation of specialized types of concrete to meet the demands of modern construction. When all the components are ready, the concrete production process begins with mixing them together. In the past, this was done manually, but today, automated concrete mixers have replaced traditional methods, saving time and increasing efficiency. The mixing process ensures that the cement particles are evenly distributed among the aggregates. After mixing, water is gradually added to form the cement paste. Hydration will continue over time, allowing the concrete to gain strength and solidity. Once the concrete is poured and compacted, the next step is curing. Curing is crucial to ensure that the cement has sufficient time to hydrate and develop strength. This process can take several days to weeks, depending on the project's requirements. After the concrete has been adequately cured, finishing techniques such as smoothing, leveling, or applying decorative coatings can be performed. Thanks to the flexibility of cement, concrete has become the most widely used building material globally, serving countless residential and industrial projects. With the continuous growth of the construction industry, cement and concrete remain integral to building durable and resilient structures. The perfect combination of science and technology has made the production of cement and concrete more efficient and cost-effective. We hope this video has provided valuable insights into the fascinating processes of cement and concrete production. Thank you for watching.